it left the city in ruin, took the plaster off the walls, tore roofs off. It was a horrendous thing. Happened in the span of 10 minutes. And it took the lives of the 29,000 people who lived there. Well, hello, George. How are you this afternoon?
I'm doing pretty well.
I was just watching the apapani and the lehua over there. That's fascinating. There's a little bird that eats the nectar out of these red flowers that you'll see in the trees here. And they flit around, really wonderful to watch. It's anyway, welcome to the summit. Were you going down to the caldera?
No, I got to go back to the phone service again.
Yeah. Well, it's a curse and a blessing at the same time. Yes. Well, wonderful. And you folks here to learn something about the volcano today? Oh, wonderful. Well, let's wander down here and take a look at the caldera, if that's okay with you. Okay, thank you, George.
You're welcome.
I'm gonna have to change my routine. Apparently I'm too obvious about the places I'm going to be here at the summit. Yeah, come along. As you come by here, you'll notice a change in the temperature and the humidity. Your spectacles may even cloud up a little bit. So we're at 4,000 feet here at the summit. It rains here routinely. When it does, that rainwater percolates down through the ground until it finds a geothermal source, then it comes back to the surface again. There's a vent right here that lets that steam escape. And so you're a witness to that part of the geothermal exercise that's going on here constantly. I'd like to point that out. For you, young lady, wonderful moisturizer for the face. For you, sir, I'd be very careful how much time you spend around one of these. It is just hot enough to take the crease right out of your trousers. Oh, looks like you found it already. That's for yourself. Yeah, come along. On the right, you'll get your first glimpse of the caldera. Let's do a little basic volcanology 101. Sometime in prehistory, before there were probably dinosaurs even wandering around on the Earth, an astronomical body impacted the Earth on the opposite side of the Earth. And when it did that, smacking the Earth like that with its molten core, the impact shot a dart of magma out from the molten core through the magma, or through the mantle of the Earth, until it impacted the crust of the Earth. And when that magma broke through, it formed lava that started to flow out. In this particular case, it would have been under the ocean. And as it flowed out and flowed out and flowed out over large periods of time, it started to form a volcano. And ultimately, those volcanoes broke the surface and formed the islands of Hawaii. The plate that it impacted, that hot spot is located underneath, is constantly moving to the north and slightly to the west at the rate of about 2.5 to 4 inches a year. And when it does that, as it moves, the mountain that's on the hot spot eventually will move off. And so the islands, all of the islands of the Hawaiian chain, have been formed here. The hot spot doesn't move, it stays here. The plate moves until it finally gets up into the Arctic plate, and it subducts under the Arctic plate, and when it does, it forms the Aleutian chain. And that whole ring of fire that people have talked about, and you've heard about, I'm sure, is all about the Pacific plate moving. But when it moves here, the hot spot stays in the same place, so the islands keep drifting off of the hot spot. So islands like Oahu, like Kauai, like the French frigate shoals, the northern Hawaiian islands that no one bothers to visit anymore, were all made here, and over the millennia have constantly moved to the north. And now we are in a position where we have Kilauea and Mauna Loa and Hualalai are still here and with the capacity to be active, probably even Mauna Kea to some extent. So that magma that forms the mountain comes up and spews out. In this particular case, that magma is very hot. And as a result of that, it tends to flow very readily. And the mountains that it forms tend to be very feminine in shape. Sorry that Mauna Loa is no longer out of the clouds, but you see a very soft, almost feminine kind of shape to the mountains here. And that's because of the temperature of the magma as it exits, and the lava tends to maintain that temperature and flow very gently down the slopes. forming what we call a shield volcano, because it looks like a warrior shield laying on the ground and has that same rounded shape. So the shield volcanoes that we're looking at here, Mauna Loa, but particularly Kilauea, and Kilauea came up off the side of Mauna Loa in subterranean or sub-sea area underwater, and finally came up and now is 4,000 feet above sea level. And as that magma comes up through the mountain and it forms and it forms and it forms, about 500 years ago, we believe that where we're standing now was perhaps as much as 300 feet higher in altitude. As magma came up and spewed out over the area, it formed the mountain up to this level. And at some point, the magma column inside the mountain got distressed. Something happened that it flowed out downslope somewhere, and the magma dropped out from the summit. When it did, it took away the support that it had. That magma column was a lot of pressure on it to move upwards, and now that with that magma gone, the summit collapsed catastrophically. Probably left a hole here about maybe as much as 2,000 feet deep, and to the area of the walls here, it collapsed into that to that level. And over the millennia, slowly but surely, magma coming into the hole that was left there filled it up to be able to make it fill the floor up, or till it filled to that floor that you see there. And that is basically the nature of shield-type volcanoes. They build up and then they collapse. And when they collapse, that hole that's left fills up over a period of time, and then it will collapse again, and the magma column will drain out downslope. Now, when this happened thousands of years ago, or hundreds of years ago, when it did that, there was no one here to record the data that was happening here. But the Hawaiians had a chant that talked about an argument between Pelée, Madame Pelée, the goddess of the volcano, and her sister, and it seems that they had an ongoing spat, and the Hawaiians had a chant about that, and they wrote off the activity that was happening here as a fight between two deities, sisters. When I first arrived here in 1909, there was a very small perched lava lake that had been here for almost 30 years at that point in time. And there hadn't been many changes in the activity that was happening here at the summit. I was offered the opportunity to come and open an observatory here because of my desire to study a volcano for a period of time, and the chance opened up here. My actual infatuation with volcanoes came as a result of some activity that happened in 1902, far away from here, almost on the other side of the earth, in the Caribbean, on an island called Martinique. There was an eruption that occurred there in May of 1902 that drew the attention of a lot of people around the world, but particularly President Roosevelt, Theodore, wanted someone to go and tell him what had happened there, because there was such a devastation. And he sent me and 4 of my colleagues from MIT and Harvard aboard a ship that took us to Saint-Pierre, the port city of Martinique, to study the effects of what had happened with that. And that was typical of volcanic exploration in those days. We heard about a volcano exploding someplace, and we run as quickly as we could to get there, transportation always being a problem. But that's how we studied volcanoes, to see the aftermath of what had occurred, and then we postulated what we thought had happened. And that was true of Mount Pelée on the island of Martinique. The eruption that occurred there, the French call a nuée ardente. Very romantic sounding, isn't it? It means glowing cloud. We call it a pyroclastic flow. It originated from the summit, 4,000 feet up, came tearing down the mountainside with perhaps a velocity equal to that of a hurricane, perhaps as much as 100 miles an hour. This cloud of gas and water vapor and dust and ash coming down the mountainside, an internal temperature of that cloud perhaps as much as 1,000 degrees Fahrenheit. And it chose to go straight through the city of Saint-Pierre. It left the city in ruin, took the plaster off the walls, tore roofs off. It was a horrendous thing. Happened in the span of 10 minutes. And it took the lives of the 29,000 people who lived there, and their pets and their livestock, all within that same span of 10 minutes. There were witnesses offshore who managed to avoid the cloud because they were on ships, but they recalled what had occurred there, and the president wanted to know exactly what had occurred and how to prevent that from happening in the future with such a loss of life. Well, we boarded the warship Dixie at the Navy Yard in New York and sailed down the coast of the United States and out into the Caribbean. And when we arrived at Saint-Pierre, my 4 colleagues and I were totally agog. There were 7 columns of thick black smoke rising from different parts of the city. This eruption had taken place now fully 2 weeks before because of the length of time it took us to get there. What could possibly be burning at that intensity for now a full 2 weeks, 16 days? It wasn't until we landed on the shore and we walked up through the streets, all strewn with rubble as they were, to the base of one of the fires. And we learned that the fuel were the bodies that were being extracted from the city. The pyres burned night and day for 3 months. Our initial reason for being there was to study the mountain. Unfortunately, one of the members of our party had been to Mount Pelée previously and was able to produce his notes from his previous visit, and we compared those to the mountain now, and there was almost no relationship to them whatsoever. After 20 days of studying the mountain, we joined in the gruesome task of disposing of the dead. After 3 months, we boarded the Dixie for the trip back to the United States. And on the way north, I reviewed the notes that I had written daily about the experiences that we had. And I concluded that the best possible use of the balance of my working life during that period of time would be to study a volcano 24 hours a day, 7 days a week, 365 days a year, to learn what it was that made that volcano work. And when I returned to Cambridge, I informed my colleagues of my intention to do just exactly that, to go and study a mountain all the time for as much time as it took for me to unlock the secrets that generated an eruption. My colleagues greeted me with a less than enthusiastic greeting. In fact, they laughed at me. Many of them scoffed and called me the scientific missionary out to save people's lives from the volcano. And it was still a couple of years until I was able to go on to Japan to be a witness to 2 eruptions that were happening simultaneously on the island of Honshu. When I made the determination that I wanted to go there, my wife and I took a train across country. We deposited our son with his grandparents in San Francisco, and we boarded a steamer there for Honolulu, because at that time there was no direct shipping from the west coast of the United States to the Japanese islands. Japan had just opened her doors to Western travel just a few years before, and so shipping lines hadn't been established yet from the west coast. When we arrived in Honolulu, my wife, who was born and raised on Nob Hill in San Francisco and is quite used to the finer things in life, was quite upset with the temperature and the humidity in Honolulu. She swore up and down that it must be located somewhere in the vicinity of the gates of hell. And I assured her that there was an easy answer for that we could go down to the island of Hawaii, we could take a train up to the summit of Kilauea, and it would be 4,000 feet, it would be much cooler there. And she agreed to do that, and we came down by small steamer and took the train up to Glenwood, and we boarded a stagecoach there that was driven or drawn by some mules, and because the track was so muddy. We came up to the volcano house, and as soon as we arrived and she was shown to her room, she was less than satisfied with what was there. And she took the opportunity to talk about that with the owner, George Jensen, and tell him about the amenities that she expected to find at a hotel so distantly located from civilization. As she was doing that, I left to come over and see this, the magnificence of the Kilauea caldera. It was a wonderful opportunity to be able to study here for 3 days, and I walked down across the caldera on several occasions to be able to extract molten lava samples out of the lava lake that was there, and to add them to my collection. And ultimately, after 3 days, we returned to Honolulu. As we were entering our hotel, I was greeted by the gentleman by the name of Thurston, and he turns out to be the publisher of the Honolulu Pacific Commercial Advertiser, the Honolulu newspaper, Lauren Thurston. He and a group of his friends have formed the Hawaii Volcano Association, and they're quite excited about the possibility of having some kind of a research station here that would draw tourists to be able to see the academia that's happening studying the volcano at Kilauea, and to be able to draw tourists here. And I told him, well, I can certainly see the need for studying the volcano. I'm not sure about tourists, but obviously that idea has changed dramatically in the ensuing 27 years. He offered me the directorship of this scientific outpost that they wanted to establish here. And I said, well, I'd certainly need to talk with my wife about it, and I'd also need to talk to the universities about the potential for having perhaps even a 5-year sabbatical to be able to come here and to spend time at the volcano. And he said, well, take your time and let me know. And my wife and I sailed off the following day for Japan. We observed the one volcano that was still erupting there. And after 3 weeks, we returned to Honolulu. When we pulled into the port there, I looked down to the end of the gangway, and there was Mr. Thurston standing at the end of the gangway waiting to get my response. He was so enthusiastic about the possibility of me being there. And I assured him that, yes, I would return to Cambridge and I would pursue the possibility of having time away from the university. When you're a salaried and tenured professor at 2 universities located next to one another, they don't like you to be gone for long periods of time. And that's exactly what they told me when I returned back to Cambridge and inquired about the possibility of taking 5 years away to study the volcano at Kilauea. Well, I was persistent. And during the period of time that I was persistent, the university at MIT received a grant from the Whitney Foundation. Edward and Caroline Whitney had granted them a sum of $25,000 for the express purpose of studying a volcano. I looked upon that money as my own, but MIT had other ideas about that. But finally they relented, and both universities granted me a sabbatical of 5 years. And MIT, in their generosity, granted me the interest money from all $25,000 of the Whitney funds for a period of 5 years to be able to use it for material and supplies. And Mr. Thurston came up with a very generous salary for me. And in 1912, I moved to the summit of Kilauea. The first thing we did, you see the mound that's over there? Yeah, that was level ground, the same as what we're standing on here, a relatively level ground. We hired a group of men to dig a hole there, 10 feet deep, 18 feet by 18 feet, and we concreted the walls in there so that we could house our seismic equipment. And we built a small wooden structure on the top of that that would house other laboratories so that we could study other things. We installed our seismic equipment. We had a Nomori thermometer that we put in there. As soon as we installed the drum, it started recording harmonic tremor. We could see the magma moving through the ground below us, but we didn't know where it was moving because we only had one instrument, so we had no way to triangulate to be able to find out where the magma was moving at. But it was quite exciting to see that happening there. And in the wooden structure above, we were able to analyze the rocks that we found around the summit, not only here, but also on Mauna Loa. And then we started using it to analyze the gases that are coming out of the lava lake. That's The gases that we were most enthusiastic about, aside from the water vapor, which is most of what's there, but we were able to analyze the carbon dioxide levels and the sulfur dioxide levels. Carbon dioxide you know about. Did you have a beer for lunch today? Mm-hmm. Oh, you did? Oh, okay. The little bubbles that are in there are carbon dioxide. I'm sure you had champagne though. So the little bubbles that are in there are carbon dioxide. And we've found that there are compatible levels of carbon dioxide and sulfur dioxide. Did you take chemistry in school?
Yeah.
You did? Sulfur dioxide, when you mix it with water, becomes?
It was a long time ago.
H2O plus SO2 equals H2SO3, sulfurous acid. But there's a lot of SO2 down there, so there's a lot of sulfuric acid coming up in that plume. Good advice for you. Stay well the hell away from there. When you inhale a lot of sulfur dioxide, it burns the lining of your lung, and your body sends fluids there to neutralize it. You drown on dry land. Trust me, stay away from there. But we were able to take a hose and roll it out so that we could capture the gases that were there, and using a pump be able to pump those gases into a metal cylinder that we could bring back to the observatory and be able to analyze the content of the sulfur dioxide and carbon dioxide, along with the other minerals that are located in the plume. Our discovery was that as magma moved toward the surface, the carbon dioxide levels went down and the sulfur dioxide levels went up. And when the magma was no longer coming toward the surface, the sulfur dioxide levels dropped and the carbon dioxide levels went back up. So it was a wonderful tool for us to look at in terms of being able to predict eruptions that took place. All was going well until 1917, when suddenly, for no reason whatsoever, the lava lake just dropped out of existence. I mean, standing there, we thought maybe it had gone like 100 or 200 feet down into the ground, but taking a large rock, maybe about 25 pounds, and throwing it into the hole that was left there and listening for it to hit the bottom. And there was no sound. Apparently the magma had found a channel out down slope somewhere, and the lava lake had disappeared. And we thought, well, that's the end of our scientific discovery here. We need to find something else to study while we're here. 16 months later, it came back. It was a wonderful thing. And it was here for all of 6 weeks, and then it dropped out of sight again. And it started doing that over the period of the next 4 years. It came and went, and came and went, and came and went. And finally, I determined that, and one of the times that it dropped out of sight, that it would be a wonderful opportunity for me to go off the island, to be able to go back to the Caribbean, to Martinique, to see what had transpired after we had left the mountain there some 21 years before. No sooner had my wife and I arrived at our hotel on Martinique when I received a cable that there was a steam eruption happening. It was something that you need to come back and see. There was a column of steam coming out of the vent that was there, that was rising up into the sky, perhaps as much as 10 or 12,000 feet in the air above the caldera floor. A giant gush of like some kind of an engine shooting steam up into the air. And my wife and I got on the first steamer we could to Miami, and then across country by train, and finally we got to San Francisco, and we boarded the steamer there for Honolulu, and it was still going. And we got to Honolulu. The Navy, knowing that I wanted to get to the island as quickly as possible, arranged for a seaplane to meet the ship. And we boarded the seaplane. I boarded the seaplane, my first airplane ride, and we took off and we flew all the way to Maui, and the engine died. And my wife was on the steamer going back to Hilo, and she got here just in time to see the last of the steam clouds before the volcano shut down for 12 years. What were we going to study? Well, fortunately, about that time, Mauna Loa started to kick up And by that time, we had 7 instruments here to measure the seismic activity. We knew where the magma was moving, and we were able to measure the magma movement on Mauna Loa. And we made a bold prediction that by the end of 1935, there would be an eruption in the summit caldera at Mauna Loa, Mokuaweoweo. And further, we predicted that it would move downslope into the saddle between Mauna Kea and Mauna Loa, that it would go down to about the 10,000 foot elevation, and that it would start to spew lava down to the floor of the Humulula saddle, and in such a place that it would move off toward the west, toward Kauai High, and would not be any problem whatsoever. December the 2nd, 1935, an eruption started to occur in the summit caldera of Mauna Loa. And further, 3 days later, it moved downslope to about the 9,500 foot elevation inside the Humulula saddle, and it started to flow down to the saddle, but it missed the target that we had set up for ourselves, so that when the lava hit the floor of the saddle, it moved off toward the east, toward Hilo, particularly toward the spring that feeds the Wailuku River, that feeds the water supply for all of Hilo. Government officials were not particularly pleased with this activity, and they contacted us as quickly as they could. They said, "Can you do something about this? Is there something that you can do to make that stop?" And I said, "Well, I don't know what that would be." And one of the young scientists who was with me said, "Oh, we could take a wagon and load it up with TNT and have some mules drag it up alongside of the area there. We could divert the flow so that it would go off toward Kauai High." And a very brief inventory of the amount of TNT that there was in the state of Hawaii revealed that there wasn't enough to make that happen. But one of the other scientists said, there are bombers. The Army has bombers at Ford Island on Oahu. They could come over here and they could drop bombs. And so I contacted the Army at Ford Island, and I talked to a lieutenant colonel by the name of George Patton. He assured me that yes, he had some bombers and they would send them over, and the following day, 7 bombers arrived, each with 2 600-pound bombs affixed to them. They landed at General Lyman Field in Hilo, prepared to go and bomb the volcano the following morning, when the air would be the densest. They took off from Lyman Field. They went up and got up to about 10,000 feet and went in over the eruptive site, as we had discussed. And the first bomber went in and dropped a bomb right directly into the vent that was feeding the lava flow. Lava shot up into the air when the bomb exploded and burned holes in the bottom wing of his biplane. He informed the others that they needed to take a higher altitude, and which they did, and they dropped all 14 of their bombs. 12 of them hit directly into the target. 2 of them dropped in Pahoehoe fields alongside of the vent, leaving craters 6 feet deep and 20 feet across. Every time one of the bombs dropped there, the flow pulsed. And the next time it pulsed. And the flow, the lead edge of the flow approaching the spring for the Wailuku River, stalled and stopped. And the lava behind it began to build up, which is typical of those kinds of flows. And 2 days later, the lava flow ceased on the side of Mauna Loa. And so we were very successful in bombing the volcano out of existence. When I wrote the paper on this, many of the people that peer reviewed it determined that the volcano was probably ready to shut down anyway, and taking the thunder out of my being able to stop the volcano at my whim. But that fulfilled my mission, that we had stopped the flow of being able to take over a human inhabited area, thus saving many lives. But now, 1939, a few years ago, I received a letter from your United States government informing me that my services would no longer be required at the Hawaii Volcanoes Observatory, that I was mandated to retire. I was about to achieve the age of 67. And I very quickly wrote off a letter to President Roosevelt. This would be not Theodore, but Franklin, who had been here. He had sat in his car right on the edge of the caldera here and had observed the volcano with me, and told me how much he supported the activity that was happening here. And I told him, Franklin, I'm simply not done with my scientific experiments here. I need some more time. And he granted me an extension of 1 year. And I thought, well, that was pretty simple. I waited for almost a year again, and I wrote another letter to Franklin and said, oh, Franklin, I'm still not done with my work here. I could use another year. And he sent back a letter that said, yes, okay, I'll grant you another year, but underlined right after that were the words, but there will be no further extensions granted. So now my time here is almost over. I've been named as the Director Emeritus of the Hawaii Volcanoes Observatory, and I've accepted a position at the University of Hawaii, located in the Manoa Valley on the island of Oahu. My wife has preceded me there to set up our household there, and I'm prepared to leave to go over and return to the classroom again after 27 years here in the field in the most magnificent laboratory in the world. And I thank you for your attention. When the building was here, the stairs were on the inside.
Oh, yeah?
Yeah, this was only done after the volcano house was built.